Ladies and gentlemen, good afternoon. I would like to present the experience gained during last 30 years in the Czech Republic during the Radon program number 1 and 2. And because we are a bit behind the schedule, I would go faster through the first slides to have more time for the case studies. So the history started after the Velvet Revolution in 1991. We got the first decree of Ministry of Health on the requirements on management of exposure from natural sources, natural radionuclides, radon included, and it showed that the Ministry of Health, which established the Radon Commission, had to pass the responsibility to the Ministry of Environment for this topic, and then the State Office for Nuclear Safety, which was established in 1993, took over the responsibility for not only for nuclear sources and medical, but also for radon and natural radionuclides. From that time, we had 2 radon programs, and we already started development of the 3rd version of 3rd strategic plan for the next decade. The legal framework is based on the atomic law. The new one was issued in 2016 and is effective from 2017 and is implementing the new EU basic standards. We have the technical standard for civil engineers. We have the methodologies issued by the regulator, by the State Office for Nuclear Safety, and these methodologies are obligatory to proceed the measurement and the calculation according to these methodologies is obligatory to all licensed companies and laboratories. And the system of the licenses in the Czech Republic is done in the way that if you want to, as a laboratory, if you want to do the measurement for official purposes, you have to have this license. And we have also guidelines for building professionals which go into more detail compared to the technical standards. And these bullet points just are introduction for the case studies or for the topics I would like to highlight based on the experience gained mainly by my colleagues from the Institute, because we are glad to have the Radon program supporting not only measurements and mitigations, but also the scientific research in this field. So the first is the increasing energy efficiency of buildings and related health hazards. Nowadays, this is a well-known and described topic, but it took time before we get enough information about it. Issues connected to mitigations of elevated radon levels. Mitigations cost a lot of effort and money, and once verified, they are usually left without any control. And this is very important to not to stop communicating with the house owners about their mitigated houses, and left the channel open for further verification. And the last is also radium is the pop star of this afternoon section, because we have also buildings with elevated radium concentration in the building material, as well as in Switzerland. So the increasing energy efficiency of buildings and related health hazards. The new buildings are nowadays built, or the construction practice is primarily focused on the energy performance of the building. Usually this is done through the high air tightness of the building envelope. For the existing buildings, they are energy retrofitted to save money for heating mainly. The energy-saving technologies, the most important or most used one are the insulation, the heat cladding, and also the replacement of windows and doors to get airtight building envelope. The health hazards are not connected with these changes, are usually CO2 elevated concentrations, radon elevated concentrations, formaldehyde, and other volatile compounds, and also moisture, which is accumulated and may result in mold growth and structural decay. The first case study is the newly built house, bungalow built in 2012 on high radon potential building site, but it was protected according to the standard. But the indoor radon concentration found after the building was finished were between 1 and 7, nearly 7 kilobecquerels per meter cube. The first diagnostic measurements found very low ventilation, except of these high radon levels. They found also low ventilation rate through the tracer gas measurement campaign. And the second diagnostic measurement went done, which showed that the radon transport path is most probably between the heat cladding of the building and the wall, and the radon penetrates through the, you have a chart here, so this is the heat cladding, this is the wall, and the radon, that was the idea how it could work. The radon from soil gas is transported through the holes of installation done by the installation of heating panels. So we did the experiment with blower doors and constant tracer gas injection into this gap, and we found a very nice correlation between radon concentration. You can see the peak after the blower door test was started or begun, and the tracer gas. So the response time between the tracer gas injection started and was detected indoors was less than 2 minutes. So we proved that this is the transport path for radon, and based on this finding, the recommendation issued by the Faculty for Civil Engineering to the Association of Builders providing the insulation of the substructure was issued how to install the waterproof membranes. And here the mitigation was done through cutting the heat cladding around the whole building perimeter. So it resulted in low radon concentration indoors, but higher costs for heating because the heat cladding was cut. Coming to thermal retrofitting of existing buildings, we done a lot of measurements, thousands of measurements, and we wanted to use them to support the hypothesis that the thermal retrofitting of old buildings really affects the indoor radon concentration. So we selected two groups of kindergartens, of buildings with kindergartens and schools, where we had the results of measurement from early 90s. These measurements were done by the bare detectors and with exposure time of 1 year. And the second group of buildings where the measurements were done, the measurements were done in both campaigns. We had these two campaigns, and we wanted to compare the results from buildings without any reconstruction done and reconstructed with tight, especially with tight windows. And we got this. So you can see that in buildings with new tight windows and with the tight building envelope after the thermal retrofitting, we got a 63% increase in radon concentration in this group of buildings. So the hypothesis was confirmed, but when we asked civil engineers, okay, we have these statistics, so please take into consideration when planning these thermal retrofitting actions, please take into consideration also radon and check the ventilation rate. And they replied, okay, you have just statistics, but what we can do in this particular house? And so we got the results from this school when they started the reconstruction, and we were asked to do the continuous measurement there. And you can see three rooms, three classrooms on the chart. And the blue one is this room number 3 with old rotten windows, and compared to the already replaced ones. And these are the data and the pictures the civil engineers like, because they have the direct evidence of what new windows, new tight windows can do with the indoor radon concentration. But that does not mean that in all buildings, kindergarten, schools, where the long-term measurement shows the elevated radon concentration, I mean the radon concentration above the reference level, that this necessarily means that the people are overexposed. As you can see here, these black parts are the time of children presence in the kindergarten. So that means operation hours of the kindergarten, and the average radon concentration is very low, because once the kindergarten is open and the movement of people is there, the ventilation rate is sufficient to decrease the radon concentration below the reference level. But once the kindergarten is closed again, or building, not necessarily kindergarten, then you can see a steep increase in radon concentration. So this is also quite important for the planning of measurement expenditures and communication towards the building owners. Sustainability of low radon concentration reached by the mitigation is very important, and we can see it now in the Czech Republic it's around 20 years after the first large or massive campaign of mitigation was funded by the radon program in early 90s, when the only or the primary way how to mitigate houses with elevated radon concentration was forced ventilation. Some of the house owners said that they switched off the ventilation because it was too noisy, it was too expensive, they didn't know how to maintain it, they didn't want to maintain it. So the radon concentration after the mitigation, or in short time after the mitigation, returned back to the previous values. Some of the house owners took good care about the system, but they never checked for the radon levels after 5 or 10 years. And nobody knows, or nobody knew before we came, that the system is not working properly. And some of the house owners did good care about the mitigation, but they did not reflect it during the reconstruction of the building. So there should be open communication channel to the house owners of mitigated buildings, especially if these mitigations were done through radon program and fund, especially with a state subsidy, because this is what we can what we got. Again, is I have three charts. 2 are schools and 1 is kindergarten. So you can see that there is no effect of ventilation system at all on the radon levels, and we are reaching levels to 2,000 becquerels per meter cube. This is again, then we have peaks of 10,000 becquerels per meter cube when children are present. Actually, this was the reconstructed kindergarten with new tight windows, and the director said, yes, there is a big device, and I don't know what's that. We have no documentation at all, and it just cost money for electricity, so we switched off. And so the information get lost forever for what's there. And this is another chart of that the standard operation cycle plus minus reduce the high radon levels, but only when the good weather was. And the last topic with the radium involved, before the Velvet Revolution, there was embargo on a lot of information connected to radioactivity. And one of these was the building material built of high radium content slag. There was a state enterprise which at the beginning of 1960 used the slag for slag panels and for building the houses, and the hygiene service at that time, it was just by a surprise out of the blue, they found that there are very high dose rate levels, and that the source is the slag, which came from high uranium coal. And so the use of this slag for preparation or for production of building material was banned. But due to the changes in 1968, all of the information were lost, and the slag was used again for the slag concrete, for production of slag concrete panels. So we have around 3,000 houses. Actually, they were called start houses for young families, distributed across the Czech Republic. And in 1988, the measurement campaign to determine the overall situation in these houses started or commenced, and resulted and finished after the Velvet Revolution. This is the chart of the house, nice family house, but the peripheral walls were built. All of them were built from the slag concrete panels. Some of the bearing walls were built of these slack concrete panels. Some of the partition walls were built of bricks. So the distribution of dose rate inside the houses is there is a large variation from room to room, and the highest values can be, of course, found in the corners of peripheral walls. The content of radionuclides, again, was quite variable in the coal. It means in the slag, and they were between. The most frequent range was between 1 kilobecquerel and 4 kilobecquerels per kilogram of radium-226. Some of the panels reach up to 10 kilobecquerels per meter cube. Fortunately, the emanation coefficient was quite low, so the radon concentration indoors resulted from the emanation from the panels was quite low, up to 800 becquerels per meter cube. And the gamma dose rates range up to 2 micrograys per hour. This is the histogram of values of equivalent radon concentration from indoors, from houses located in Prague. You can see that the only 6% of buildings had radon concentration above 400 becquerels per meter cube. Those gamma dose rate more than or above 80% of buildings had the maximum dose rate above 0.5 microgray. And this is these are current data. These are data from 2 years ago. The personal dose equivalent rate continuous measurement by the inhabitor of this building. So it's not that you spend all the time indoors on the worst place. So yeah, and at that time, after this problem was identified, the recommended values for indoor radon was 400 becquerel per meter cube, and for gamma dose rate 2 micrograys per hour. And the sum rule was developed taking into consideration both hazards, and this sum rule was used for decision making in regards to governmental support towards the house owners of these buildings. Public awareness. It was very interesting because after the Velvet Revolution, the society started to use their powers and their rights, and they were aware. The owners were aware of who is responsible for the situation of their houses, and they wanted the government to redeem the houses, and there were strikes in front of the governmental buildings that we want the government to take care of us. And then in 1991 the government agreed and offers two options. You can sell your house, and the government at that time paid approximately 40,000 euros per house. It was 1 million Czech crowns, which was compared to the cost of mitigation. They offered 10,000 euros. It was not that good offer, I mean, to sell the house. So only 4% of owners sold their house. The others accepted the mitigation. which was done through the forced ventilation in all of the cases. And at that time, also the other remedial measures to decrease or to shield the gamma radiation from the walls was tested or were tested, and it was rejected as not effective. And this experience had, of course, was emphasized in the development of regulatory framework, because we had from 1997 we had already the regulation of content of natural radionuclides in the building material. We used the activity index and we limited the radium-226 concentration in the building material. And time went from the 1997 up to the year 2000, 2010. No one heard about the START buildings, but they still existed, and the house owners changed. The buildings were inherited or sold, and lots of information was forgotten and lost as well. And also the energy retrofitting campaign or programs fell also all this type of buildings. So this is an example of thermally retrofitted START house. They use the standard procedure, heat cladding on the bearing walls and the roof. And these are the results of what happened if the source term of radon concentration indoors is only the building material. These are the results before the thermal retrofitting and after. You can see the increase of 2 to 5 times higher values compared to the ones before the mitigation. So the reasons, possible reasons, were the decrease in ventilation, which was confirmed by the air exchange rate measurement, and the increase in radon exhalation rates due to the use of the claddings, which was not confirmed. And as the mitigation, again, only the increased ventilation was possible, and the house owner of this building and the owner of this building chose the improved natural ventilation, not the forced ventilation, because it was too costly for her. And the last part of the story of START buildings, and I will be quick but this is the most funny one. If you want to demolish this kind of house, you can do it either by yourself, I mean to demolish it and to remove the material to the landfill. That's okay. There are no obligations regarding this. But if you want to demolish it by a company, you have to measure the radium content in the building material. If you are above the clearance level, you have to commence the norm workplace during these demolishing works. And you have to do all the things written in the law and the decrees, inform the regulator, carry out measurements of personal doses, assess the effective dose of members of the public caused by the discharge of the material, ask the regulator for license, or if the dose is below 0.3 millisieverts, you can discharge it without license. You have to provide all the information above to the regulator, and you have to store the information for the next 30 years, which makes these buildings undemolishable, according to law. So this is the summary of my presentation. Buildings built of material with elevated natural radionuclide content can be mitigated by increased ventilation of indoor air to remove radon. In case that the radon source is only building material, the source time is stable and thermally retrofitted houses can be mitigated by increased ventilation as well. You just increase the increased ventilation. In case that the radon source is not only building material, but also soil or water source, the design of corrective action must take into account both of the sources, and especially forced ventilation in under pressure mode can make things even worse, because the increased suction effect for the soil source part. Removal of gamma radiation is almost impossible. LED shielding can be applied only to the worst spots, to the hot spots. Some of the issues connected to start buildings went already to the court. The court never questioned the measurement, which were carried out by the properly licensed measurement laboratory according to official methodologies. And radon was considered as a consequence of elevated radium content, which was considered as the main issue and as an undiscoverable defect of the building. Not only energy needs, but also indoor air quality should be considered when planning the energy conversion of buildings. There is still limited, at least in the Czech Republic, there is still limited harmonization between energy savings programs and indoor air quality programs, radon program included, and measured ventilation rates according to our experiences and experiments are also in new buildings are very low, often below the hygienic requirements issued by the Ministry of Health. Once finished and verified to be effective enough, the mitigation should be followed in time by repeated verification measurements, and we should keep the communication channel to the owners of the buildings open, and also and support them with measurement. Thank you for your attention.